today's session. So let's start today's session. We left yesterday that topic. Basically, we have tried to find out how we can go for those abstraction and decomposition help us to actually study a particular large system. Okay, so let me share my presentation, then I will continue. Can you see this screen now?
Yes, sir.
Okay. These are the things what we have discussed in our previous class that how you can deploy those principle of software engineering to overcome that human cognitive limitations, or so what we call the human limitations. So two way that we can take up a abstract view on some kind of systems, and if I have a large problem, then I have to decompose it. Means I have to break it into the smaller chunks or smaller modules, and goes on solving the small modules. So because my problem is divided into smaller parts, so if I just goes on solving that those small parts of my problem, so at the end when I complete all my small modules to be solved, so I can find my large problem is solved, or actually my system is ready. Excuse me. So, so these are the points what we have discussed in our previous class. Okay. Just recapping that few things what we have done in our previous class. Now, let's start with one question. Just 1 minute. There is a problem in my PPT that one animation is still there. Just remove the animation. Excuse me. Okay. So we start with this topic that, or basically, we have to go into that some condition that why we study for this software engineering. Okay. That first, the question one we can answer that why you study for software engineering is that to acquire skill to develop large programs. Okay, as we have discussed previously, that if I have a large problem, that is my large program, because I have to write down some kind of software solution for a manual system. So in that case, I have to develop a large application. So we have to study the software engineering to get the skill to develop these large programs. So that is also be clear from that first definition what we have discussed from that AI IEEE. So there is, so you can find that we have used that systematic approach. Okay, we go for a systematic approach, and there you have to take up some kind of those skills, how to get a quantifying, and we have to go for how to develop those operations, all this. Now, when your program grows exponentially, that complexity is increased. So that is, we say that exponential growth in the complexity and difficulty level with the size, means with my application size will be increased, so it will be more complex and the level of difficulty will be also increase. Next is that why we go for to acquire the skill for that developing these programs. So because the ad hoc approach, okay, used to break down the this ad hoc approach break down the size of the software when it is increases. Okay. Now that means it says that ad hoc approach breaks down when the size of the software is increased. It means as we think about that initial approach was to that build and fix. Okay. When usually we have a very small problem to be solved and we are not working in a team, so one person can work in one application area or one problem area. So that is what we think about. And when you apply this approach, okay, uh, in a large size, okay, so it is not feasible or it is not work properly. Okay, so it is not fit into that system. Now, second thing, why you go for that to study software engineering is to we have developed the ability to solve complex programming problems. Okay, so in that case, what you have studied that we have to break down the large projects into the smaller and manageable parts. That is what we have discussed in our previous class about the decomposition. Okay, and we have to acquire or learn the technique of how to specification of a problem. We have to design it. We have to design a interface for your development. Then we go for the testing. Then we have some project management skills we have to develop. Specification means you have to find out what is the specification of that particular problem or what are the actually we call it the requirement specification sometimes. As we take up that example of that library management system, so in that case also you can find that you have to find out what are the specifications you need for that to develop that library systems. So as we talk about that how you can find out what are the requirements of that, so that is the basic operational requirements you have to use. Okay, so that we'll discuss later that some kind of functional and non-functional requirements are there. Okay, so those specifications we have to find. Based on those specifications we have to design that particular system, and to interact with that system you have to develop an interface. Okay. Now suppose whenever you switch on your systems you get a uh, desktop on your screen. Okay, so when you get that particular desktop on your screen, okay, so what you find that that desktop gives you that how to start your application or if there is some kind of interactions you can find over there. Okay, so that is that sometimes this interfaces also plays a major role, okay, to develop and design. Okay, then in a one small thing I want to put into here regarding the interface design. Now think about that Windows, you are familiar with the Windows operating system and you are working with a different kind of Windows applications. If you mark the Windows, whenever you open a window, you can find the menu in the top. Just after the first, you can find in the window you have a top one, the title bar. After that, you can find the menu bar. Okay, so normally you can find a a standard window. Okay, whenever you open any window, okay, in Windows operating system, you can find that is first is your menu bar, title bar, then you have the menu bar, and in this menu bar you normally can find the first menu option start with a file. Okay, then you may find that edit or some other menu options. Okay, you have, and there is a some kind of consistency in the all the windows. Okay, normally kind of the finder file, edit, view, about, help. These are the orders. Okay, and you may have some changes. Okay, based on that kind of application this window meant for. If it is a notepad window, you can find that file, edit, view, that kind of things. Okay, if it is just Windows Explorer kind of the file is there, then you have some other view is there, but other extra menus are also there. And you can find the left corner is usually for your title, that application title. Maybe it is written, if it is notepad, then it's notepad. If it is Explorer, then it's Explorer, like that. And in the right corner, you can find those minimize, maximize, and close buttons are there. Okay, now you can find this style is followed in all Windows, in the Windows operating system environment for all applications, almost all applications. Okay, so why it is so? Because you are familiar with this Windows style, so easily you can know that what actually file is used for. So now most of the cases you can find in the file you have a file, either open a new file or to save a file, minimum menus. And there is a, to close this one you can find the exit button is there, or option is there. So that means when you go for the, after designing a system, when you go for the interface design, we find that if this consistencies are not maintained in our Windows, so it is very difficult to use it, because I cannot remember all different kind of windows for the different applications. Okay, so if there is some kind of consistency is not maintained, so that is the interface development is a very crucial part. Other aspects are also there, like sometimes you can find out that whether those color combinations you are using, okay, is it soothing to your eyes or not. So that is also one aspect, okay, of that computer science we are studying, that HCI we called. You can find this SCI, some SCI concepts are there in their uh, the software engineering modules. Okay, you can find. So we call it as human computer interface. Okay, so that means you can find, uh, if you open any standard window usually, or the desktops, now you can find the very different colorful desktops are there. And normally the displays we are using also having low radiation display devices are there, so because that light radiation is less. But usually you can find most of the cases their background is blue. Okay, in the windows you can find, in the standard window you can find their display background is normally it is blue. Why they choose this blue color? Okay, for because when the user is interacting, or if you're sitting in front of a system for long hours, okay, so due to this radiations your eyes are get tired. And it was fine, or this actually research find out that blue color has that minimum radiation, okay, apart from the other colors. So that is the reason most of the cases. Okay, and that is the reason that sometimes we design some presentations also with the blue background. It is my also, it is blue background. Okay, I have designed it anyway. So that is another aspect to make you understand this concept. So that is the interface development is also there. So we have to learn all this technique when we study this software engineering concepts. Okay, apart from this, how to go for this specification of a problem, and then you have to go for a design aspects, how to make work. Okay, then testing, we know that we have to, whatever application we have designed, okay, we have to find out some test data. Okay, based on that test data we test that whether that particular module or that particular applications is actually working properly or not. So that can be a very small program. You can, so you can take up that small example. Suppose I ask you that you just write a program to check whether it's a prime or not. So how do you test it? So you can first you give the known data, means you know that this number is a prime number. So normally you say that you can give the 5, 3, okay, 7, this type of numbers. Then we know this number is a prime number. Okay, so we have to give that known result to test it whether my application or my that small program is working properly or not. Okay, so That is what we call, we have to prepare some kind of test cases, we call it. Okay, so based on that specifications provided by that particular client. Okay, so we have to design it and we test with that one. So if it is give me the correct result, so my software is correct. If it is not, then I have to find out what's wrong with that. Okay, and to perform all these operations you have to go for this project management skills. Okay, how to manage it, how to distribute this modules in different teams. Okay, how you can arrange those logistics and all details. So that is what you have to learn in this kind of techniques you have to learn in this study of your software engineering. Next. Okay. Okay, again, just 1 minute. Okay, now next is that we have to acquire some better programmers. Means we have to acquire the skill to be a better programmer. Okay, so why we have to have a higher productivity and better quality programs. Okay, now when you talk about this the study of software engineering and all this. Okay, so that goes for different things. Now suppose how you can say that this programmer is a better programmer or all this. So what kind of skills you expect from that? Okay, so that means if someone is designing particular application. Okay, now you need a higher productivity, means that programmer must have some standard skills. Okay, now suppose when he designs some kind of small program or approach. Okay, that he have to take care of that what kind of logic he has to use. Okay, which will gives you that minimum resource utility and all these things. Okay, so you can take up some examples. Okay, now think about that. You just tell me one answer that you have studied your data structure, right? In your previous semesters, maybe the first or second semester, data structures, or it is in this semester. Okay, data structure. Have you studied data structure? Okay, are you there? Or is disconnected? Okay. So anyway, so my question was that why we study the data structure, or what is the actual use of the data structure when you are writing a software or writing a program? Is there any utility? So you have studied, suppose, simple logical structures, maybe stack, maybe queue. Okay. At least one application of stack and queue. Can you suggest any application where we have used the stack or where we have used that queue in programs you have used? Now, one generalized example. So, suppose when you working with these windows and you want to close a particular application. Okay, suppose you have opened your notepad, you have opened your paint, you have opened your word processor application, suppose maybe word. Okay, but without closing any of this application, you suddenly go to that particular windows start button and you have to shut down the system. So what will happen in that case? What you find? usually you can find that it suggests that, or it's ask you to close these programs, then it will go for the closing that windows. Okay, so that means if I have open a number of applications one after another, okay, when I want to close them, so normally it is goes in that order. You can find that whichever the application I start last, it is closed first, then goes on in that way. Okay, so how you can maintain this kind of sequence, that is whichever the application I have to start last and I have to stop later or sometimes, okay, in a sequence. So here you can find there is a order is maintained by a tag applications we are using. Or think about that how you can perform this arithmetic expressions to be, suppose I have to add 5 plus 6. Okay, I have to use or I have to add 5 plus 6. Now how you can or how my system know that 5 is a number, plus is a operator, and 6 is another number. Okay, or operand and operator, this concept. Now there you can find that we apply or you have to use a stack. So how? So you have to use a stack to convert this infix. We call these are the infix expressions to postfix expressions. Okay, and then we can go for that, evaluate that postfix operation using a stack. So you have to push all these operands first, then you have to push the operator. Then we pop the operator, then we pop the top two operands and perform that operations that operator we have. So that is some thing we have studied. You have studied. I hope that you have studied these operations. So that means you can find that everything whatever you have done. So that means if you don't have a sound knowledge of the data structures, okay, you will not able to write a simple applications which will be, suppose I'm thinking about that, whenever someone has written that code that how to add two numbers in your system. Okay, so how it can perform your system, that operation level. So these are the applications you can find. So to acquire this kind of skills, you should have this knowledge. So these are the reasons why you will go for to study of your software engineering. So, but okay, anyone to say something? Okay, so next is we have to go for the software crisis. Okay, now in the software crisis, what you have to study that or we have to find out some kind of this crisis. Because of that, okay, we have to go for a proper designing and all that. So software as a product. Okay, now sometimes when we design the softwares, we fail to meet the user requirements. Okay, that means that user has given some kind the requirement specification, but whatever the product you have designed, that is not gives satisfied that customer. Okay, so these are the some kind of crisis you can face when you go for that software designing, and at the end you can have that kind of product. Now your software may be frequently crash. Okay, so why you're sometimes you can say that you say that okay, this program has crashed very frequently. Okay, so that may be the due to the design fault, that may be a simple logical fault by the programmer. Okay, your software can be crash. Now let me give you one example that a simple problem. Okay, so you may face while you're designing. Okay, if you don't aware of these things, I talk about that those things like the data structures and all this. Now, just tell me that you have some idea about your C++. I told you, or yesterday I just talking about that, or I expect that you have some idea about your C++. Okay, as you told that, yes, you all of you have that idea, the C++ programming, right? Now, in C++, when you create a class, you can find that we create a or use a constructor. Okay, so can you tell me what is the use of that constructor in a class? So you just interact, please interact. When you create a class, okay, you just write in class. Okay, suppose class name is A. Okay, you have or you may have created a constructor like this. Yeah, right? Now, what is the use of this constructor? In it is a C++ syntax. I can use a semicolon over here.
Hmm.
Yes, actually it is not audible. Anyway, this is normally you say that to
Sir,
initialize your. Yes, yes, Devasis.
sir, can I
Yes,
say?
yes, yes.
Sir, sir, a constructor is a member of function of a class which initialize object type of a C++.
It is okay. Uh, okay, it's correct, but I have to just rectify things. Okay, so it is that constructor is similar to a function, a member function, you can say. Okay, it is not exactly a function because the function has a return type, but here you can find that we don't have any return type in this particular, but that syntax you can find it is similar to that of your that function. Okay, now anyway, so you can find that constructor start with that name of the class. Okay, we may have some arguments over here, may not, and we have this opening and closing braces. So where usually we initialize the member variables. Okay, or the class member. Suppose if I have a class member here int x. Okay, so I have to initialize this x with some value. Let it be 0. I have written. Okay. So in a constructor. Now similarly, and I hope that whenever you have designed any simple class, okay, in your previous C++ programming, you have created this type of constructor so many times. Like if I am creating a student class, okay, so my class name or is class student, may be representing a student information. Okay, you may have created that type of constructor. So suppose I have a roll number here, okay, maybe int type, and you may have created student roll equal to suppose some variable, some value 100 I have given. Now this is a constructor. Okay. Now similarly, sometimes in C++, okay, we use a destructor. Okay, or I'll write it separately, it will be better. So we use a destructor here. Sorry, just a minute. We use a destructor. Normally you can find in C++, we write a tilde symbol before that class name, and then we just like a constructor, we create this. So we call this is a destructor. Now my question is that, as you told me that the constructor used to initialize a member variable, okay, what is the use of a destructor? And if I not create a destructor in a class design, whenever I'm creating a class, okay, what is its implication? Means what is the problems may arise? Okay, so I'll take up a small example in this. Now, can you tell me what is the use of a destructor? Okay, so the use of destructor is to make your object free, or basically that memory allocated for your object, it will be free. Okay, or sometimes we use a terms called the garbage collections. Okay, so actually what happened, whenever you're creating a class, okay, and you're creating the its object, and you goes on creating the object. Suppose I have creating some certain class, okay, called student. Suppose s1, s2, s3, like that number of object I am going to create it. And some part of my applications, these objects are in use. Okay, now my memory management says that whenever that object is out of scope, means that object use is complete, or it is function is complete in my that particular program, that memory allocated for that object will be free. Okay, it is get freed. So that is a automatic process by your memory management of your that particular environment where you have written that program. So you can say that the runtime of your that C++ environment, it is the job of that compiler. He has to free that memory. Okay, and as I told that destructor job also the same, that is also free the memory. But sometimes we declare this destructors in a class explicitly. Sometimes we don't. We don't write this one. Okay, sometimes. Okay. So the question is that if I not write or a particular constructor in my class also, then also my application runs perfectly. There is no issue. Okay. Then why I have to write a destructor in my, or when I have to write this type of destructor, or I must have a destructor for a class definition. Okay, this is my class definition. I must have a destructor. If I not have this destructor, then what type of problem is there? Because I want to come up this particular problem that my system is frequently crash sometimes. Why? Okay, so this type of problems arise. You say that this is a bug in my program. This is a bug. There is a bug in my software. Means some logical issues are there. Okay, so my program can run for a certain period, but when I working on a longer period, it is suddenly crash or it's not performing well. Now I'll take up this example for this one. So think about that. You have created a class called the student, and here you have to create a character pointer to store his name. Okay, this I'm just writing in my finger. It is not clear. Uh, so let me erase. Okay, then I try to write it a little bit clear so that you can understand the things properly. Because we try to explain that why we need this or take up this software engineering seriously, because this is the basis. So suppose if I create a class, I'm just using some abbreviation student for STD because I have to write less. So I have one only two members I am take up. Let's say one is roll number. Okay, I'm using R, and another is your name. So for that I have to use a character pointer star. Okay, name. Let's say, and I want to initialize this two. Okay, so for that I have a constructor std. Okay, let's say I'm just using some fixed values. Roll number equal to 10. Okay, now I have to give this, initialize this name with some value. So in that case, what you have to do in this case? So first you have to allocate some memory to this pointer, right? So for that you have to write what? Nm equal to new, okay, char the size, okay. Due to the space problem, I'm not writing here. Okay, new char, okay, sorry, new, okay, char. Then you have to provide the size. Suppose whatever that 10 byte or 20 bytes, or whatever you have. That means my focus on this new keyword. So what is the job of this new? So this will create a dynamic memory allocation. Okay. And I close this class. Suppose I have not given a constructor here. Now what exactly happen when you create an object of this one? Suppose I have created a object standard std student, s1 is the object. Okay, you created. Now in my memory, usually you know that all our regular variables or the local variables, okay, take a memory in our stack, and all those dynamic memory allocations take up the memory from your heap. Okay, one is the stack area, okay, another is the heap area. Okay, and we call, there is a call stack. I'm talking about data structure just now because of this. Okay, so in that case, when I write this type of line, okay, I'm creating an object s1. So we say that objects are runtime entity, means dynamically allocated memory. So it will be allocated memory, whatever the requirement. Suppose one is your roll number. Okay, suppose you say that roll number is 10. Okay, another is a name. Suppose ABC you have to store here. So what do you have? This is name is your, this, you have written this name as a new, okay, cache. That means this name is having some kind of address, and as you have used a new, another allocation is done. Suppose somewhere here you have written that ABC, some allocation is there. So this is a reference, okay, and this allocation has a reference in your call stack. Suppose here I am writing S1. So that means this is actually referencing to this particular address. Now when my application goes on executing, so my stack is get popped. Okay, when this S1 job is over, it is get popped. When it is get popped, so that means this allocation don't have any reference in my this call stack. My runtime system, okay, this memory management system, okay, what we call that garbage collection, okay, is actually, or garbage collector, monitoring the stack, and it's fine that for this particular allocation there is no reference in this particular stack. So what it does, it is dereference, it means it is delete this area, so that my memories get free. So this is what is called that my. So that means whenever an object is goes out of scope, so that is it is job is over. So there is no reference in this. So that address is allocated to that particular object is get freed. Okay, right? So it is get freed. Now in this case, you can find from this that this memory is free by your garbage collector or that memory management or runtime system. But what if this particular allocation, this is remain there? So this memory is free, so this memory is allocated, but there is no reference anywhere, so it is remain there. Think about that, you have designed a student class like this, and you are having a large applications, and you have created 1000 students, and you are working on that. What happened? So this unclaimed memory is grows up in your application memory address, and time comes when your address space is full and your system get crash. Okay, so why? Because you have not given any provision to make this particular memory over here, this line, okay, this particular allocated memory to be get free. So whose fault this one? Who designed this class? It is his fault. Okay. How to resolve this problem? Simply I have to write a destructor here. std here, and only one line I have to keep here. What? I have to write delete, okay, this name, this name variable. So that means whenever this particular object memory is going to be claimed or by my garbage collector, so this destructor will be called. So what is find this destructor? There is a statement called delete name. What is a name? This is a name, so it will be first free. So it will free, then it will be free. So there will be no unclaimed memory. Okay. So these are the small things. So that is what we talk about, that whenever you're creating some products, so this type of crisis are there. So sometimes knowingly, unknowingly, this type of problems happened. Okay. And my system get crash. Okay. So you have to take care of this. Okay. At the time of your design. Okay. Is it clear? Whatever I try to explain you, that this is one example I try to cite. Okay, that why the system crash frequency, that may be many other reasons are there. Okay, so this is a very common simple problem, okay, while we are designing this type of classes. Yes, is it okay? So I have to explain it is very in a limited way, because the writing scope is very limited here anyway. So this is small. So that is what you can find, that when I'm designing this type of class, so I must have a destructor. So if it is asked that when you must have a destructor in a class, so only one line answer you can give. If I have use any dynamic memory allocation in my constructor, okay, then I must have a destructor to free that. Okay, so in that way you can just make your application more efficient. So this is what I have cited. This is the one reason of your sometimes this small application we design, but it is get crash. But initially, if you run for a one or two students, you may not feel that one. Okay, but when your application run, okay, for the larger application, suppose you have 1,000 students and all this, so this particular unclaimed memory may create some kind of problems. Okay, and when it will be crash or you don't have any idea. Okay, so you cannot predict that one also. Now, sometimes the products are expensive. Okay, I'm just clearing the screen. So sometimes that products are expensive, means why that product get expensive? Maybe in terms of your resource allocations. Okay, maybe because your application you have designed, it may be require more resources in terms of memory, in terms of your other storage devices. Okay, in terms of display, suppose you need a high resolution graphics and all this, so that may increase. In terms of that crossing the deadlines of your project completion, that is also expensive. If you cross the deadline, so you initially you have estimated your that software cost for a period of 1 year or 2 years. Okay, if your deadline cross, so that means another 1 year is added into that project. That means another 1 year's logistic cost, means the salaries of those programmers, developers who are working on that. Okay, the cost of that particular infrastructure you are using, maybe starting from your systems, that electricity, that ACs, those facilities you have provided, internet facilities, everything. So that is incorporated, that cost of your software. So that is sometimes you get expensive. Okay. Now, sometimes your softwares may be difficult to alter, debug, and enhance. Nowadays, we are using some kind of programming paradigms. Basically, what I cite this example of the object-oriented concept. So we can say that we go for from procedure to this software, that object-oriented concept. One major reason is that reuse. Okay, that means I can design a particular component based development. I design a particular class, that is one kind of component, and that I can be used in different other projects. Okay. So if I have independent components, so I can manage it well. But if I have only single approach component, so if I want to change a particular portion of that particular software, so I have to rewrite that entire application from the beginning. So that is sometimes we call that altering is difficult. Okay, and if a single large program is there, so debugging is also difficult. If you have a modular programs, okay, small modules you have created, so you can identify easily the which module is having the problem. So that particular module you have to manage or modify or alter whatever you can do. Okay, so these are the some software crises you have. Okay, and as I talk about that, and some reasons you may deliver late. Okay, now sometimes there is a I'll just end today's class with this software myth related to this the late project. Okay, so it is said that there is a software myth that if you add more people to a late project, make your project late. Okay, so that means normally what happens, suppose in other engineering fields, okay, if your project get late, if you add more people, sometimes you can enhance your delivery date. Means you have to complete your work in a stipulated time and you can deliver that particular product in time. But in case of software, it is not the case. You have to decide your project team from the very beginning, and you have to keep that team, okay, till end of that particular project. If you alter or change that team, so it may late your project. Why? Suppose you have assigned a particular project for 6 months, okay, and you have selected 5 members, team members you have. Now you can find, so there may be any reason, okay, you can find their project is getting late, so you try to add more people into that project. Okay, at the mid of the project, let's say already it is 4 months is completed, and only 2 months left to complete your project, but you have not, you find that it is not possible to complete, so you have to add more people. So in that case, what happened normally, those peoples are not aware of that project, that environment. So who can train them or who can tell them better about that project? Those person who already in that project. Means suppose you have already late project, you have 5 peoples, okay, let's say 2 peoples engage into train the new peoples you have added them. So that means what happened, that now this actual product delivery depend on only the 3 people who are working. The 2 hours are busy to explain the things to the newcomers. So okay, in that is the reason that if you have a late project and you are adding more people, so sometimes it makes late. Okay, so if you are adding the people, then you have to be send the trained peoples, already trained, and those who have that experience of that similar kind of project or same project. Then only your project will be delivered in time. Okay, so these are the various software crises we have. Okay, so we have to take care of these things during the design or that software project design or specifics and aspects. Okay. Then another cause of the software crisis or something, sometimes you're not able to use your resources optimally. Okay, when you talk about the resources means you have to find out that all your resources, maybe that can be your memory you have for that system you design. Okay, so suppose execution time, suppose what are the specific memory you require. Okay, unnecessary you may have make your project heavier. Okay, with in terms of memory, in terms of the storage you are consuming. So you have to optimize them. Okay. So you can take up that previous example what I have said, that if I have not used that particular destructor there, one small thing. Okay. So sometimes you can find your memory is consumption more. Okay. Unnecessary that unclaimed memories are there. So your memory is consumes more. So that type of resource you have to be managed. Okay. So sometimes your resources are not used optimally. So these are the few points regarding your software crisis. Okay. So some of the factors what contribute to your software crisis. So those factors we may discuss in elaborately in the next class. Now you may ask some questions if you have any doubt. We have another 5 6 minutes left, so you can just ask your questions whatever I have discussed today. So we can continue that one. Okay. So I'm just stop sharing this window. Okay. Okay. So if you have
Sir,
any
the example of
hmm? Example, huh?
sir, the sir, the software crisis example.
That memory structure I have discuss about that C++ problem. Okay.
Sir,
See, that is the reason I ask you that how much you have done that C++ programming. Anyway, you have basic idea what is a constructor, what is a destructor. Okay. Now, try to understand that how actually whenever you're creating an object, how that object get memory in your system. Okay. Now, usually, whenever you start any application, or how actually this memory is allotted to my application. So we say that there is two kind of data structures are involved in that. Okay, so what you call the memory dynamics. Okay, if you remember that basic diagram, okay, I'm just sharing one same presentation I'm sharing. Okay, because I want to write something. Okay, 1 minute. Okay, I need a blank screen, so I'll just use this one. Okay, now you can see this one. Okay, now if you remember that in your memory dynamics, okay, if you remember that diagram, because so usually when you start your program or any program in your memory, there is a code area. Okay, then we have a data area. Okay, sometimes it's code area known as a text area. Then you can find, okay, there is your memory it grows in two different ways. So this is what you call this is my stack. Okay, here to here you can say a stack, and here to here we have, or we just mark it like this. Okay, you can just heap area. So heap grows in this direction. So that means this is my address space allocated to a particular application. Okay. So code area, sometimes you can say that text area, something in memory management we call it. Okay, so this is my normal application, and these are basically that addresses, okay, where this is allocated. Now think about that I am just writing a program, okay, main, some variable I have int. Okay, so this instructions are actually kept over here, that code area or the text area we have. Okay, and this variables what you can find, okay, are mentioned in this particular data area. Okay, and then all local variables are those, suppose here I try to call a function, suppose main is called. Okay, so it is pushed into the stack, so this stack is goes. So here this is what roughly I am designing this one. So that means I have two memory structure or data structures are using in the memory. One is called the heap, another is stack. Okay. So usually whenever I create, I just erase this one. Whenever I run my application, if I say that I have two dynamics are there for the memory, one is heap area, another is a stack area. Okay. So how to create a or declaring any variable? Suppose if I write, again I am writing suppose main. Okay, any variable, suppose if I write int x. So now what do you find? What type of memory will be allocated to this x? Okay, we call it as the auto type. Remember those storage classes: auto, extern, okay, static, and register. So all local variable, this is a local variable. So within the main I have declared, or in any variable I declare within a functions, or in C++ we have the member functions. Okay, in Java we have a method. Whatever the variables we declare inside a method function, so these are known as the local variables. So all the local variables get a allocation or pushed into this stack. So if I say the x, so this x is over here. Okay, and the value is over there. Now similarly, when I declare an object and create an object, now remember that when always you say that whenever you're creating any object, you just write your class name and then you are writing your object name, let's say S1. If it is a C++. In Java, you are writing your class name, object name equal to you're writing new. Okay, then you are writing the constructor name. This is the Java syntax. Now you can find this new. So remember that this new, okay, or in simple C we can use malloc, okay, or calloc, this function. The purpose of this malloc or new is to allocate the memory dynamically. Means at the time of program execution you have to allocate. So whenever you use this new or this malloc, that memory will be allocated in this heap area, because they are randomly select a memory area and access it, means allocated from this one. So this is not in sync because stack is a sequence. Okay, so but heap you have to go for the dynamically, or that is a randomly you can select any memory address available over here. That's the purpose we are using the random. Now suppose when you say that S1, what you call it is S1 is an object, it is a reference variable, right? We call it as a reference variable. So, and it is allocated some memory based on that particular class structure you have defined. So that is what I say that suppose I have in my class, I have one roll number, another is your name. Okay. Now these two members are there. Okay. So for them, for roll number, suppose it is integer type, so I need some 4 byte. Okay. For name, how much byte you have to specify. Okay. So for that, again, you have allocated dynamically. Suppose I have a 10 byte size of memory. So this is my 10 byte. So this is here you have the address. Here is the reference. Okay, this is net. You can see that I'm writing this way. So this is to show you that, okay, if I take up 10 bytes, so this type of memory is allocated, let's say, for diagrammatically. Now, who is referring, suppose this particular area has an address. Okay, so this address is referred by a reference variable called s1. This is my object. Okay, so when my program execute, suppose this s1 is written, suppose line number 1 you have created, so it is pushed into the stack. Then you may have called s1 dot, suppose some member variable you have, function you have, so it is line number 10, let's say. So when it is reached to the line number 11, okay, and that statement you have pushed over here, suppose s1 dot, so it will be popped, means it is free from, or is popped from the stack. Now your garbage collector or that memory management is constantly monitoring this stack. It's find that here I have a memory address, suppose say 1001. It doesn't have any reference in this particular stack. So that means its job is over. And as long as it is in this particular call stack, we call it as a call stack. Okay, means it is in execution. Means this line is crossed. Means execution of this function is complete. Okay, you are going to the line number 11. So means this line is executed already. So it is popped from this. Okay. So when it is popped, and that means this reference is not no longer available here. So that is, this is subject for your garbage collection or subject for your to be free. So that is what we call that no longer this object is needed by this particular application. So make it free. Okay. So this is the way your this garbage collector or that particular memory management or runtime memory management is works. Okay, to identify that which part to be removed or free from your disk because it is not required. This is about your just memory management, how it is works. Okay, is it clear now? Okay, I free this one. I just going back to, okay, Devasis, is it clear now? So
Yes,
what
sir.
I suggest that you just refer to your those memory management using your this operating system concept. So there you have that how a application is allocated the memory. Okay, so just go through that particular diagram, it will be clear. So there is a diagram is there. What I say that code area, data area, and that code segment, or sometimes we call that code segment and data segment, and then you have a heap and stack allocations is there. That diagram is there. It will be clear. Okay. So I end today's topic here. So we'll meet in the next class. Okay.